Hi, welcome to Life of a Google API Developer. My name is Mark Stahl, and I'm here with Tony and Aiuto and David Gibson, some engineers with my team at Google, and we're going to be talking about what it takes to start getting started developing for using APIs at Google. So just a little bit of procedural information to get us started. If you're going to be tweeting, we have a couple hashtags we'd like you to use so we can see what everybody's saying about us. And we're also using a new service that will let you give some feedback after the session, so you can tell us how you like it or whatever. So these links will be available after the end of the talk, so feel free to not copy them down right at this moment. So just a brief outline of what we're going to cover today. First, I'm going to do a little background so you know who this talk is geared to. This is a 101 level talk, and people who are just getting started developing APIs. So in that spirit, we're actually going to build an application. We're going to walk you through the process that a new developer, dare I say a little cowboy programmer, might use in order to sort of go through the process of actually trying out, learning the APIs, and actually developing them and getting a working sample. Finally, we're going to take a little deep dive into one of the newer pieces called the APIs Council, and we're going to talk about how you're going to manage your projects. So we've introduced the concept of a project at Google, and this is how you establish a relationship, and you get a little bit of feedback on your traffic. So, and then we'll just do a little wrap up and Q&A. So starting with the background, this talk is a beginner talk. It is a 101 level session. So we make some assumptions that you are familiar with Java, you know how to program, but we do not assume you have any particular experience with Google APIs. We also we're going to take the position of a developer who likes to sort of dive in, learn, and sort of learn by experimentation. While we say that this talk is built around Java, just so you know, the concepts you learn here should apply to any language. So if you're coming from another language, don't be discouraged. You'll still get a lot out of this talk. So also, I'd like to talk a little bit about which APIs we're talking about here. At Google, we have many APIs. Some, I don't know, I've heard the number 80 bantered around. You can go to our code website and see the actual number. We're talking here about the RESTful APIs. About a year ago when we talked, most people didn't know what RESTful was, or it was still growing in importance. These days, REST is pretty well understood. They're very simple and easy APIs to use. They are built basically straight on the HTTP protocol. So you use HTTP verbs to manipulate what they call resources. And a resource is usually just a document living at some well-known URL. And in our case, all our documents we recommend these days are written in JSON. All of our new APIs are now being built on a common infrastructure. Last year at Google I/O, we did a presentation, a little behind-the-scenes look at how Google builds APIs. And if you want to listen to me speak a lot more, you're willing to go to that URL and check out a little bit more about how we build APIs. And it'll also give you a much better introduction to what RESTful architecture is. So in the last year, we've introduced several new APIs on this new infrastructure. Today, we'll be using the Buzz API and the URL Shortener API. But there are some, 13 APIs now or out on that infrastructure as of today. A lot more as of this morning. And you can go check them all out, see what's available. In this talk, I'm also going to introduce several of the new tools that we've introduced in the past year. And as a developer, you're going to find these tools very helpful with getting started with developing for APIs. The first tool that you'll all probably want to really know is we call the APIs Explorer. This will allow you to sort of play with APIs and learn about them, and I'll introduce that a little later. We're also going to present the Java client library that we've released, and we're going to spend a lot of time delving into the API Council, which is where developers live at Google. So let's start right in on our core task. We're going to start building an application. And anybody who's built an application, some people say that a lot of the best applications happen because everybody has a personal itch to scratch. So the first thing we need to do is find our inspiration. What is it that bothers us, or what we think we can do better? What is not being done today? So let's start with a personal one that I find kind of annoying. Here's a link that takes me to my particular Buzz posts. So if we go to this screen, you can see all the Buzz posts that the Google API developer user, have made. And there's a couple little entries here, and each one is accompanied by one of these very long URLs. And so it sort of occurs to me as a programmer that, wouldn't it be nice if, let's see if I can get this to change slides, that would be good. Wouldn't it be nice to have these URLs be nice short URLs, clean up my Buzz posts a lot? Now, of course, I could just shorten my URLs manually. So every time I post a Buzz, I go to the browser, I cut the URL, I go to a URL shortener tool, or I have a little hot button, and I take the shortened URL and paste it in. So I can manually do all this work. But, it would be really nice if Buzz were to sort of auto-shorten my URLs for me. But, of course, Buzz doesn't do that, at least not yet. So, but then I realized there are APIs for these things. So, I can build the app for that. At least I think I can. So this is what I'm going to build. Today, we're going to walk you through building a URL shortening agent that just watches your Buzz feed and cleans up your URLs for you. So in order to know whether or not we can build this using APIs, of course, now is the point where we're going to want to dive in and learn about the APIs and see whether or not they can do what we're trying to achieve today. So first step, of course, all good developers do is they sit down and they read the documentation from end to end, right? Yeah, so not true. We have some really great documentation, great reference guides. You're going to want to get into that eventually. But a much better step 0 would be just to go try them out and get familiar with them and see what they can do. So to that end, we have built a tool that will really help you get started. And we are introducing this tool in the last few months. We launched the Google APIs Explorer. So this is a web-based tool. It lists all the APIs that we currently support on the new infrastructure. And it allows you to make these requests and actually see the responses. And when I say make the request and see the response, you can actually see all the HTTP interchanges that are going on. And this will really help you when you're trying to learn about and, most importantly, debug your applications. Because you can actually make the mistakes in the API, the same ones you might make programming. You can see how the systems respond. And you can sort of learn how to adapt and how to fix them and actually work until you get the correct responses. And we also support authentication. So a lot of the APIs require you to be authenticated before you can actually access private data. The Web API Explorer supports that, so we can actually do everything in the API Explorer that any real application can do. So let's go take a look at it. The API Explorer lives on the code site, code.google.com, and this is the URL, and let's go check that out. So we start up here with this screen. This shows you a list of APIs that are available in the service. And as I said, it's a fairly large list. I don't know the exact number offhand, but it's growing a lot right around Google I/O. And we'll start here with the Buzz API. So let's select that. And you see there's only one version available. And we have a nice link to that documentation. So when you're ready for reading a little bit more in depth, that's where you're going to go. And here's every method and operation that you can do in the Buzz API. As you can see, the Buzz API is, well, it's quite a long list of things. So let's start with the ones that are most important to the application we're trying to build. First thing we need to do is get a list of our Buzz activities, which are all those great posts I showed you in my feed. So here's one. This is called Activity List. And we click that, and here's a list of all the parameters that I can pass into that. Now, I'm going to, first of all, the parameters here shown with the asterisk are the required parameters. So there's 2 here that I have to do, which is the user ID, who am I actually accessing, and that's going to be myself. So I do know that there's a token from reading some documentation, that there's a token called @me, and that tells me that to use whoever is the authenticated user who's actually making the request, that's the person whose activities I'm going to list. Next is I'm going to want to set the scope. The scope is a description of once the activity list allows you to list different types of activity events, and there's actually a whole bunch of different groupings that you can choose from. The one that I'm looking for is the self group, which is the group of activities that I myself have posted, as opposed to comments, activities that other people have done, or things that I'm receiving from other people. So this is the self scope. Next, you can see there's a lot of parameters that are optional that I can supply. Alt equals JSON. This one is hardwired into the Explorer, so you're getting JSON responses. And I'm going to say, oh, I only want to get the max results the first 10. So now I've constructed a request in the Explorer. Let's execute it and see how it looks in HTTP. So, very first thing that happens is I get an error. Before I look at the error, let's look at just the request itself. You can see right here on the URL, this is an actual HTTP request being issued by the Explorer, and this is the API. It's very simple. So you can see in here there's a URL, Google APIs, where all requests go. You can see that I'm accessing Buzz version 1. I'm accessing the activities feed. The required parameters you can see right here, @me and @self, which we talked about a second ago. And you can also see a lot of these optional parameters, the JSON, max results, PP, that's pretty print, so we have readable output, and key, which we will cover later. And all this is just done with the HTTP GET request. That's it. That's the API. And there's a small user agent, of course. And here I can see the response that I got back. In this case, I got a 401 unauthorized. And that the Explorer itself has warned me, this method requires you to be authenticated. Obviously, we forgot to authenticate. And it even tells me you need to switch to private access, which I'll show you in a second. So let's go try switching to private access. I can close the history pane and go back to this. Now, up in the Explorer, you see here it says using public access. I'm not actually logged in as anybody or have any authorization. I'm going to switch to private access. I'm going to be using something called OAuth, or in this case, OAuth 2, which is the second version of the OAuth protocol. And I'm going to grant me as the person as the user of the API Explorer, I'm going to grant to the API Explorer application the permission to make requests on my behalf. So in order to do that, the API Explorer is going to generate a request to Google. Google's going to show me a little dialog, and I'm going to click that there. I'll show that in a sec, but first I have to choose also the scope. The scope is a list of when I grant authorization to this application, the application is going to request a certain amount of power. How much authorization does it really want? And in this case, the Buzz scope is what we call it. The Buzz scope says the API's Explorer application is requesting ability to read and write all my Buzz feeds, to pretty much have full control. There's also another scope called Buzz Read Only, you can see. That is, if the API Explorer is going to choose, only has the ability to read things but not to write them back. There's a Picasa one, which limits you more to the photo sets of the API. And so when every API publishes a certain set of scopes that it supports, and as the developer, you actually choose the scope. Normally, in the Explorer, of course, we let me, the user, choose the scope. But normally, you as the developer are going to choose the scope. And really, you want to choose the scope that's the least powerful so you don't scare your users by asking for too much. But in this case, I need to read and write, so I'm using the Buzz scope. And I'll switch to private access, and a little window pops up. So here it says, Google API's Explorer is requesting permission to manage all my Buzz activities. Exactly what I want. Here's a small detail of the types of things I'm giving it permission to do, and a little bit more info, which tells me who wrote this application and where the redirect is going to go after it's done. So, of course, I want to allow access. And now you see that it says here on the API's Explorer, using private access. So let's try this same request again. This time, you can see that it executed moments ago. I actually executed the request. I now have a new authorization header using OAuth with a very large, complicated token. And I got back a response. This is a 200. I can actually see in this response all the headers that I got back. Again, a really great debugging tool. And the JSON body. Here it is. So you can see here, there's one of my object contents. This is the actual object content. This is my Buzz post right here. Stormy weather for Amazon Cloud Services. Oh, that's probably not politically correct. So anyway, this is just an example. Let's go back to this tool. So just a little bit more about the API's Explorer before I go on. Google launched just yesterday. We introduced a new API. We call it the Google API's Discovery Service. And it provides a list of all APIs and a mechanical, machine-readable description of how they operate. And this service, if you want to learn more about it, you can go see a talk tomorrow at 10 in the morning. There's a presentation just on this APIs and how we use it to construct client libraries. We also use it to construct things like the API Explorer. The Explorer itself is a completely dynamically driven service. So anytime Google launches a new API on the API's infrastructure, it shows up in Explorer and you can play with it. So it's a really cool tool, and I invite you all to check it out if you're interested. So let's go back to next step. So just to recap what I've done so far, using the Explorer, I was actually able to show all the behaviors that I wanted to show. So you're actually now ready to start programming against the actual APIs. However, I'm actually a manager. I don't actually get time to write code, but I have, I'm in Google. There are a lot of great engineers here, and in fact, Tony is one of them. He's going to come up and actually show you how to program the API.
Thank
Tony.
you, Mark. Good morning, everyone. So to begin, I have to get my tools in order. And the primary tool I need is a client library. We have libraries that we've recently enhanced in the last few months. We have them for these 5 popular languages. We have more coming. They all share common idioms. They're all open sourced and lived on code.google.com. This is just the landing page for the thing. You could browse here for documentation and pointers to each. Each has its own site devoted to its own examples and sample classes. Today, we're going to use Java. I hope that's appropriate for this audience. But the things I teach you will be applicable to any language, should you choose something else. Oops, slide. Oh, too far. I'd like to talk about the Google APIs client for Java. This is now in version 1.4 beta. At the bottom is a base library that provides mechanisms for building HTTP requests, creating and parsing those responses in JSON and XML, and OAuth 2 helper classes. The HTTP transport is, you can plug in whichever one you want because you use different ones in different environments. People writing mobile apps on Android would probably use the ones bundled with the Android SDK. If you're writing a web server app, you may use a different one. The same goes for your JSON and XML parsers. Android uses JSON very often. Most people use the Jackson parser. They have different memory and speed footprints. Authentication, you saw a little of in Mark's talk where we had the failure and then we had to give permissions. It's a complex topic. We have a lot of helper classes to make that easier for you. Above the base library, we have API-specific libraries. So there is one for Buzz, URL Shorten, Moderator. These are built with the discovery mechanisms. In the same way the APIs Explorer generates itself on the fly from discovery, we can use this to generate strongly typed Java libraries. They consist of a service factory, which makes the requests to the service, and data model classes, which represent the actual data elements that the service provides. I said these are now in version 1.4, announced in beta this week. We can go to the landing page for that and take a look at what it is like. Yeah, from here, there are links to the developer's guide, setup tools, documentation for both the base library and the API-specific libraries, and samples you need to get started with. Now, real programmers don't necessarily read the documentation. I'm hoping that I can find a piece of code on Google's website that'll do roughly what I want, and I can learn from that and use it as a base to build the application that I'd like. And I am lucky here because we do have samples like that. So somewhere in the code site for the API library, we've found this set of examples. And there are things for BigQuery and Buzz and Calendar. More get added. These are open source. We accept contributions from the crowd. I'm going to take one of these Buzz ones and do what I would do with any piece of code I find on the internet. I'm going to load it up. I'm going to compile it and run it, because what could possibly go wrong? So let's see what happens when I run this piece that I pulled from Google. Let's make that a little bigger. I can make it even bigger. It is running. It is building a URL to pop up that authentication request, like what we saw in the API Explorer. It's popped up, it popped up a browser window and immediately failed. And it's failed with this message, invalid client. So, not totally despondent. I can go back and do what real programmers do, which is read my comments. Early on, I see this block of code, and these two lines immediately draw my attention. They say enter client ID and enter client secret. Clearly, these are values I have to provide. Fortunately, there are comments nearby in the code saying that they come from the Google API's console, and there's a link to the API's console sitting there. So let's follow that link and see what we have to do at the console. We have to start a project. I guess so. I'm going to identify my project. And I know I want to use Buzz, so I'm going to do that. And I've got the terms of service agreement for Buzz, which I think I will agree to, so we can proceed. And we'll accept that. And I also know I'm going to want to use the URL shortener, so let's just accept that now. Now, the comments were about access, so I'm going to go to the API access, and I need an OAuth2 client ID. So let's create one of those. My product will be LOGAD 11. I do not have a logo yet, because I'm just a small company. And I'm going to select an installed application, because the app I'm running is running on my desktop. It's not on a web server. A web application would be something out in the cloud that you can refer to. Installed apps run on your desktop. Client ID. And now I've generated these three items here. Client ID and client secret. That sounds good. It ties in with my code. I redirect URI, which is a funny string here. We'll come back to that. Those were the elements we just generated. I'll go back to my code, and I will cut and paste them in. Now that I've done that, we can look a little at these other fields here that are also authentication related. The redirect URI you saw on the API's console, that's a special marker to say this is a native installed application. The scope below it, Mark alluded to in the API's console. It was the right that we're asking the user to grant the application. This is the ability to read and write my Buzz posts. And let's see how the sample looks when we finally run it. If I can learn to type. Okay, we're creating a little local web server to get a redirect. We've built the authorization URL that's going to pop up the browser window. And this is great. We've seen the same kind of authentication window that we saw in the API's Explorer. My app here is looking to manage my Buzz activity. I will allow it access. The window closes. I get a response back saying it's OK. Now we're asking the OAuth server from Google for a verification code. And we see one of these strings that looks very much like the string we saw in the API's Explorer that was posted into the request. And now I see my Buzz posts, or I see Mark's Buzz posts listed here. Great. At this point, I know that I can run an application. So it's time to look through the sample code, learn how it works, and then I can use that as a base to finish. Early in the code, I see this. It's creating a transport level for the HTTP requests and a JSON parser. These are a pair that are appropriate for an installed app. Right below it, I use those to create a Buzz object. And that Buzz object is going to be my handle for creating requests to the Buzz service. Right below that in the code, I see this. We're taking that client ID and secret that were pasted into the app, making an identity object, then using the identity object and the scope, so it's my application and the rights it wants, to create this local server flow object. This is a helper class that's provided with the example that runs through launching the server and doing this OAuth dance and this flow that gets you the authorization token. We call that local server flow object to get the access token, and then we call the Buzz set access token to brand that into every future request. So that's how it slips into the HTTP headers. And this sample hides a lot of the details of OAuth 2. We're trying to make it easy for you, but it is a complex subject. And a little later on in the talk, we'll go into that in much more detail. I see below this some code that actually makes a request. Here, I'm building an activities list request by calling this constructor for it. You'll see this is identical to the request Mark's made. I've passed in me and self, the two required parameters to this. I'm setting the optional parameter, max results. We do our required parameters in the constructor. We do our optional parameters just as setting on the request below it. Finally, I execute that request and get a response. And the response is not just a block of JSON or XML. It comes back to you a fully formed object that can be of any depth of complexity as required. That object happens to have an array of activities in it called the feed items. I can loop through that array, take the buzz object from each, grab its content, which is actually in my post, and print it. Now, this idiom I've just shown you is used in all of our client libraries. We always build a request, we possibly let you modify it, we execute the request and get results. So what you've learned here is applicable in any language you want to use. And I know what I have to know, so I have to sit down and start doing the code to finish my application. And I'm going to begin at the bottom, writing some of the grunt work things that I need. I know I have to go through a string, look for URLs, and replace them. So I wrote a little replacer. And it works by taking a block of text and a regular expression, letting you iterate over that block of text with the next operator. You can pull out the current match, see that string, and replace it with something else if you choose to. And finally, when you're done, you can grab the resultant modified string. Coming up a level, we're going to want to make shortened URLs. So I'm going to have to add the URL shortener to my application. I've accepted the terms of service and turned it on in the console, so I'm ahead of the game there. And now I have to add a factory for building URL shortener requests to my application. And it only adds 2 lines of code here. I import the thing, and I create a URL shortener object. I'm reusing the same transport and factory that I used for the buzz object because they are thread safe and reusable in that way. You should only need 1 buzz object, 1 URL shortener, 1 transport, 1 factory for an application of infinite complexity. So my inner loop to create requests looks something like this. I make one of my replacers out in the code somewhere. I have this hairy regex that detects URLs. I run it over a piece of text looking for them. If they're already shortened, I skip them. But if I want to shorten it, I do this. And this is exactly what Mark did. We create the body of the request, which is a URL object. I set the long URL. I create an insert request with that body. Then I execute the request, and I get a response. That response has the short URL in the ID field. I can replace that into the text, and after I've iterated all of them, I can return the result. The outer loop that calls this looks like this. We iterate over the activity items in my activity feed. I take the content from each. I shorten them. If it's changed, I want to update my buzz post, and I do that by creating an update request with the required me and self. I have to give it the ID of the activity that I'm updating, and I give it the modified activity. I execute that request, and I get a result. Let's see if it works. It's doing the same OAuth process, starting the server. It's building the URL we're going to direct the user to and popping up a browser window for them. Great, I see the application. This time I've added URL shortener to my list of scopes, so I see that. We're going to grant it access. We're finishing the OAuth with the verification code, turning that into an access token. And great, we're going through the posts. I see the long URLs. I see them shortened to something. I could declare victory here, but really, I should go check to see if anything happened. So let's look at Mark's BuzzFeed. There we go. They're all short. And I'm going to declare victory at this point. Okay, so now I really know everything I need to write code. I know how to create a handle to a service. I know how to authenticate it. I know how to make requests. What I don't know is how to manage my success as a developer, because if I want to deploy this, I have a real project. I'm going to have to manage that in some way. For that, we have David Gibson here who continue the talk, and he will explain that in all the detail you need to know. Thank you.
Hi, I'm David, and I'm here to tell you about the rest of your life. And the rest of your life, as you know, once you've built the app, there's still, well, most of your time is spent managing it and making sure that it keeps on working. I've been working in the API infrastructure group on various developer-centric features on the infrastructure side. And the way it gets exposed is in terms of all the various project management features. The story is going to involve talking about sign-up, talking about access in a bit more detail, and then talking about our various traffic controls. So sign-up. Sign-up really means that you're becoming a partner with Google in serving Google services to the users of the web. Our combined mission, as it were, is to make the web better for everybody. And what this means in practice is that you get various tools to track how your app is doing, and also that Google gets to know who you are, so that we can reach out to you if there are problems, and we can reach out to you if there's new features or changes that you should be aware of. It also means that we get to serve traffic to you and not the bad guys. There are, unfortunately, a lot of people out there who are trying to do things like search for every single restaurant in Europe. And that's not a good use of anybody's resources. So we'd rather be serving traffic to people who are serving real user use cases. OK, sign up sounds a bit complicated, but actually it's very easy. Tony's walked you through the entire flow already. All you need is a Google account, and you select the APIs you want to use, you accept the terms of service, and you're done, you're good to go. When you want to go back to the console, you'll see there's a whole lot more features there. You can invite other team members for either read-only access or actual edit access to your project. And you can set up access credentials, and you can manage the traffic controls. Now, I do want to talk about terms of service a little bit more. OK, I'm an engineer trying to sound like a lawyer here. But it's actually not true that the lawyers made us do it. It's actually more true that we made the lawyers do it. And we very much want to encode the responsibilities on both sides here. We want to make sure that neither Google developers or Google suddenly gets a surprise and gets subjected to something they weren't expecting. So I do encourage you to read it. You only need to read it once, and in fact, the console will only ever show it to you once. And as you read it, bear in mind that the motivation for it is to improve the web experience for the end users. OK, enough about sign up. Now, Tony started talking about access, and I want to cover it in a bit more detail. There are really two separate purposes for which you're going to need to identify yourself, and that's to access Google services and then to access user data with the user's permission, of course. And these are usually called the two-legged and the three-legged cases. In the first case, there's two legs, it's just you and Google. In the second case, there's you, Google, and the user who are all entering into a relationship. You may ask, what if you don't identify yourself at all? And yes, you can experiment completely anonymously. Don't expect to be able to launch your app anonymously. You'll find that as you experiment, you're going to get limited service access. Some APIs don't want you to experiment anonymously at all, unfortunately. Most APIs are going to grant you a pretty low QPS for experimentation purposes. And of course, don't expect to access users' private data if the user doesn't know who you are. Let's go to the simple API access case where it's just you wanting to access a Google service. All it needs is an API key, and it's designed to be grab and go, very simple to grab and deploy. Here's an example. Here's the URL shortener application with a key at the end of the URL. And in fact, I encourage you to click on this link now. This link here is the same as the long link above. And it calls URL shortener with that key, and we get the same result as before. I encourage you to click on it now because we're going to get back to that a bit later. One other thing to mention here is that the security is pretty simple. It's what you see here. It's a shared secret. If you are accessing it from your server, call us with HTTPS and don't let anybody else access your server. If you're calling it from the browser, it's obviously on the open web, but you can lock it to just the referrer of your site, and I'll show you how to do that. The three-legged case now. Tony has covered most of this already. I do want to point out on the side here that both the keys and the secrets can be revoked at any time should you suspect that someone is abusing it, or you just want to change your secrets. This is like a password, and they say that passwords are like underwear. You should keep them secret and change them often. So the OAuth 2 story. What we are trying to avoid here is expecting users to give their password to you when all you want to do is access their BuzzFeed. The password is too powerful a credential to hand over. So it consists of 3 steps, and the first step is really the most important. This is what the user will see. It's the permission dialog. And knowing most users, they're going to see it and click allow immediately without really reading it, but let's look at it in a bit more detail. Mark's shown you this already. It's viewing your URLs, and it's actually got the email of you, the developer, and it has the URL, including the site name of your site, which gives the users something that they can identify with and decide whether they're going to trust or not. Once they've consented, the rest of the flow is behind the scenes. Because there are various different use cases, the flows, as they're called, are slightly different. From JavaScript, there's a access token after a pound sign. There's a web server flow. There's a local server flow, which is what Tony was showing. And step 3 is what you really wanted to do, which was to access the user's data. And you put a token in the URL, and that token encodes who you are and who the user is, and you get the user's data. And it's actually a step 4, which is that the user themselves may at some point decide that they don't like you anymore, they want to clean up who they've granted permission to. They can go to the accounts.google.com page, and as you see here, this user is granted access to the URL shortener, to the API Explorer and the URL shortener in particular, and they can revoke access instantly. This is a very quick tour of OAuth. There will be a talk tomorrow, 1:45, covering a lot of these topics in a lot more detail. So we've covered 2 of the 3 points. The sign up, you should only really need to do once. The access, you should hopefully only need to do once, but you might need to revoke your keys at some point. The traffic controls, you might want to monitor continuously on perhaps a daily or weekly basis. So with all these new APIs then, we have a default daily limit set up per day, per application. The limits are fairly large. They are sufficient for many small to moderate sized sites. For the case of Buzz and URL shortener, it's 1 million queries a day, which should be enough for a lot of sites. That said, more is available on request. If you actually fill in a form and let us know who you are and your use case, we are more than happy to grant you more, academic users in particular. And lastly, we are introducing some billable APIs as well. First out of the gate are custom search and prediction. Now we get back to the point that this is a shared responsibility between Google and you, the developer, in that while we grant your entire app a daily quota, users could still accidentally or on purpose exhaust your entire quota if they hit you hard enough, because it is shared among all your users. So you get to decide, based on the kind of traffic that your app has, whether you want to set a high query per second rate for each individual user IP or not. If your app is particularly bursty, you want to set that high. If your app, the users are only going to access for once or twice per day, then you can set that limit low. It all depends on your traffic patterns. You may ask, what if your users are querying your server and your server is relaying that request to Google? And we have thought of that. There's a very simple way of just putting that user's IP in the request URL, and Google will do all the metering on your behalf. Now, lastly, billable APIs. When there are large sites out there querying Google, they do and will eventually incur real serving costs to us. And well, there's two real ways for dealing with this. And one is, as I've mentioned, you set limits. The other one is you do the obvious business thing and you start charging for Google's costs. This payment system is also, if you think about it, a way to improve the quality bar. It becomes a lightweight business relationship between developers and Google is providing a quantifiable commitment that these APIs are going to be there and are worth something, and it enforces quality on both sides in that way. The actual sign-up process is very simple. You sign up with a credit card in the API console. You get to choose the daily maximum because, after all, it's your money. You decide how many queries a day you will tolerate, and the API infrastructure will enforce that. It's important to mention that all APIs in the project get the same, will get the billable limits. So you should really keep two projects around, one for experimentation and development work, and one for production where money is going to be charged. And then you get a monthly bill through Google Checkout, and a pretty familiar mechanism. Okay, it is now time for a bit of demo and walking through a few of these features. Here's that URL again. Try hit that application, and I'll show you what happens in the console. Let's try the development link. So on this project, here's the traffic control screen. It is currently accepting requests from any referrer, which means that your requests should be going through, and we can verify and reload here. Yes, they are still going through. But if I reconfigure this, I can say, well, actually, yes, I want it from browser scripts, and we can pretend I own that site. If anybody actually owns that site, speak up. But we update that, and it takes a minute or two for caches to clear, but if you're hitting that URL, we'll give it a few minutes while I talk about other things. That access should be shut down for anybody except people coming from that site. So there are per user limits, which I talked about. The URL shortener is set fairly low, which we don't expect users to hit much. Now, and there's a limit of a million queries a day for the URL shortener. Now, if we were to turn on billing, let's do that. We'll go to the production project. It would look like this. So URL shortener doesn't have a billable limit. It still uses the million. And the custom search API, which does, has increased to 1,000 queries a day. Let us verify that. OK, well, I need to talk more slowly, and eventually access here will be blocked. I do not exactly have time to talk more slowly, so experiment with this on your own. The last thing I want to show you, though, is that based on the traffic, you can see that, and if you start hitting that URL more, there it is again, NHM7A. You can see me experimenting in the week before the conference, and you can see the traffic is starting to spike today. And these graphs are real time up to less than a minute. And this is starting to offer you tracking. It's starting to offer you some simple analytics. In this case, there's referrer base and different APIs. Translate is going to show you breakdown by language and things like that. And you can track to see how close you're coming to quota and what kind of users are reaching your site. Has the numbers actually changed? It hasn't actually changed. OK. All right. That is the end of my very brief tour of the console. I'm going to hand back to Mark to sum up.
So, thanks a lot to the engineers who do a lot of this great work for you guys. So, you've now seen pretty much this is pretty much what you need to get started as a developer of Google APIs. We have built a lot of new technology. Just to wrap up, we have the APIs Explorer. So if you're in that get inspired learning stage, this is a great first step to take. Just go and play. They're all there waiting for you to try them out. If you want to start coding, we've got lots of client libraries. So go, and we've been concentrating heavily. Our developers have told us over again that they really like samples. That's how a lot of people get started. And so we are concentrating on our client libraries, which all follow the same patterns, and samples for every API we can get around to writing. And all the projects are open source. So if you don't see a sample and you want to submit one, we take contributions. We take donations, And also, we've built this new API Council. This is where you establish your relationship to Google. It's a two-way relationship. You get a lot of information back. We get a lot of information back. And you can manage all the authentication and registration procedures, which traditionally were very hard for APIs. They're all centralized in one place. All your keys, all your management, it's all centralized. You can change your keys and revoke. You can monitor your traffic. You monitor your billing. It really makes life really easy for developers to get started. So we have just what's next. There's a lot more information here. First off, the sample that Tony ran today, we have actually put the code up there. So if you want to build a URL shortener agent, we built one for you. Go ahead, download the code, see how it works, try it out yourself. We did remove all the keys, so you're going to have to add your own. But since then it's your project. We also have a lot more APIs. Google has a huge website devoted for developers. So go check out the code.google.com APIs link, or any of the new tools, obviously. You can go try them. And more client libraries. So pick the language of your choice. So this is to get you guys started. The Google APIs are a big topic at Google I/O. There's a lot more talks that you can follow on. So just a brief rundown of other places you may want to go if you want to learn more about programming. One, of course, Android. We have a whole talk today, I believe it's just after this one, that discusses just the techniques you're going to need if you're writing for Google APIs on Android. It's a different environment, but it's the exact same client library. Different transport, it all works together. But if you want to do Android programming, we also have built an extension to the Eclipse environment. So if you want to work on a project in Eclipse, download into Eclipse. We build a plugin for that. There's a talk this afternoon on that. So that's one of the new features is API support. Tomorrow we have two talks as well that I'm going to point you to. First is we talked about the new Discovery API, which we use for building these client libraries across all these languages. So you can go check out on that. And as David had already mentioned, for those who want to really understand authentication and how it works, tomorrow there's a talk tomorrow afternoon as well. So that's everything we have. Google APIs are open for business. We're looking forward to all the great apps you guys build. I'm open for questions and answers. And if Tony and David could come up. So thank you. And just a word, procedural word, if you want to ask a question, if you could please use the microphone so other people can hear you.
OK, I've turned on the multi-factor authentication. Does that change any of the flows or the approval screens?
I'm sorry, I'm not, which?
I've turned on the multi-factor authentication in my Google account. Does that change any of the approval screens or any of the workflow experience?
Multi-factor, yeah, I know where it actually does impact. One of the things we didn't show in these diagrams, the web browser was already logged in as the test user. And when the user logs in, that's the point at which they see the login username, password, and two-factor auth. The approval dialog comes after that. So this presumes post two-factor auth flows. It's just part of the flow. Does anybody else have any other questions?
Sir, over there.
Hi. The Python client library, is that App Engine compatible? Can I build
Yes,
applications
it is.
on App Engine?
Yes.
Yes.
In fact, it's one of the interesting parts about the Python library is it's completely dynamic. Python being a dynamic language, it literally works with every API out the door that comes on that runs off Discovery. It downloads Discovery, builds the library on the fly, and makes it available to you. So it's, and the developers are around here somewhere, you know?
Yeah.
So it's ready, and App Engine is one of its target places, so it's ready to go.
Thanks.
Yes?
Hi guys, thanks for the talk. So as a developer, if I request a set of services and I get, maybe my app's really good and thousands of people grant access to my application, and then I add a new feature at some point, which now requires additional services that I need access for. What do I do with all the existing OAuth tokens? Do I have to basically get everybody to reauth, or is there a process to sort of upgrade the existing people?
David?
Yes, you will need to reauth because you can't do anything else with users' permissions. You're violating their trust if you don't. Right. The OAuth flows, I believe, will do that completely automatically. If the user's already authenticated, they won't show a second dialog. If you're adding something, it'll automatically show a dialog to the user again.
Okay. Right.
This is the same. This is the exact same flow you'll notice in Android applications. Mm-hmm. If a developer, say, when an Android application, it's very similar to OAuth. You declare your required permissions on the phone. If the developer upgrades the set of permissions, the install dialog re-shows and requires them to re-authenticate. It's the same with OAuth too. You have to ask for the permissions you want. That's really the basis of it.
Yep.
So.
Okay. Thanks.
Over there.
Hi. Sorry again. I don't want to start a high rest versus low rest holy war, but I was slightly surprised that the result of a post to the collection didn't return a 201 created rather than a 200. What we're seeing is a 200 okay when you create a new URL shortener, for example. Has there been any thought in that direction?
It probably should be a 201, but I don't know why that was probably just that particular code. There's no, I would have thought a 201 as well as an insert. Oh, actually, I know why. Probably because the item already exists. We've shortened the Google.com API URL before. So
it's put.
We could try it out on the Explorer and see what happens. Yeah. That would be my guess. And if we have time, I will. But if it's okay with you, we can get some other questions, and we can try it out on your. You can either try it out on your own, or we can try it right here.
Thank you.
Yeah.
Do you guys plan to make changes to the APIs as you upgrade them to the new system? Because the calendar API is a little bit of a mess if you want to get all of your events. Mm-hmm.
Seriously, yes.
Yeah.
We're not trying to migrate our services blindly.
Okay.
We do ask them to rethink, because a lot of services, that was their first version, and as they come on, they have new versions, we ask them to rethink their APIs.
Okay.
We've also built, you see in the URL structure, we built versioning strongly into the system to make it easier to support upgrading versions in the future. So.
Okay.
Yeah. If you have a specific suggestion, send it to the calendar team.
Way to get all the events from all the calendars instead of having to get the list of calendars and then every event from each item in the list.
Yeah.
Right.
Nice.
So do we have any other questions? All right. Thank you very much.
Thanks, guys.